Hi everyone, my name is Pradyumn, and today we'll discuss the solutions to the first four problems from today's CF round, which was Division 2. So let's begin. So here we have the first problem, which is called El Fucho. Juan and his friends are going to split themselves into n teams and play a modified double elimination football tournament consisting of a winners group and a losers group. Initially, all teams belong to the winners group. In each round of tournament, the following happens as long as one of the groups has at least two teams. All the teams in the winners group pair up. If there's an odd number of teams in the winners group, then there would be a team that didn't get selected and didn't get paired up, and so it wouldn't play a match. That team stays in the winners group. For the teams who got paired up, each pair plays a football match in which there are no ties. If a team wins, it stays in the winners group, and if it loses, it moves down to the losers group in the next round. And same in the losers group. Losers group they pair up, so they make some pairs, and whoever wins stays in the losers group, and whoever loses gets eliminated from the tournament. So basically, what we have here is like there are two groups, winner group and loser group, right? And here there are some teams, and here there are also some teams, and basically in every round they pair up. So like these two pair up and these two pair up, and then what happens is um basically they play a match, right? And whoever loses in the winner group, this is the winner group, so whoever loses in this group will go to this group. Like let's say this player wins and this player loses, then this player will go to here, and this player will stay in the winner one, right? And same for this pair, the loser will go here, right? And also in this round these two will play, and the winner stays here, and the loser gets eliminated from the tournament. Loser gets thrown out, right? That's what happens after every round. In every round, I mean. And also, if there's odd number, like if there is an odd number of teams, there are 5 teams here. Then one of the teams don't play a match, and they will stay in the winners group. All right. So this will happen until and unless there are more than 2 players or greater than equal to 2 players in each group or in any of the groups, right? So as long as the winners group has at least 2 players, this will happen. And as long as the loser group has at least 2 players, this will happen, right? So finally, what will happen is one player will remain in each group, right? One player will remain. And finally, they will play a match. Okay. They will play a match, and then someone will win, and they are the winner of the tournament, right? So yeah, that is what happens in this tournament. That is the entire statement of the setup. And we have been given that initially there are n teams. Initially there are n teams in the winners group, and there are 0 teams in the loser group. And we have to determine that what is the number of matches that will be played in this tournament, right? So let's say, for example, we have in the samples n equals to 3, right? So they have given us one of the possible standings. So initially everyone is in the three group, like the winners group, right? So for example, it might happen that 2 and 3 play a match and 3 loses. So in the next round, 3 goes to the losers group, and two remains in the winners group because it won, and team number 1 also remains in the winner group because it did not play a match, right? Then in the next round, 1 and 2 will play a match, and let's say 1 loses. So 1 will go here, right? Because it lost, and 2 will stay in the winners one. And now there is only one team in the winners one, so nothing will happen. But in the losers one, there are 2 teams, so they will play a match. And let's say 1 loses, then 1 will get eliminated, right? And 3 will remain in the losers group. And finally, 2 and 3 will play a match. And let's say if 3 won, then 3 wins, right? So there are total 4 matches that were played. That is this 1-2, 1-3, 2-3, and this 2-3 as well, right? So the answer for 3 is 4. Okay. So this was the problem. It was a very pretty long problem, to be honest. But the logic is pretty simple. Okay. So basically, instead of just thinking about the tournament as a whole, just think about what the teams are going through, right? Just think about this problem from the team's perspective. Okay. So what will happen is if any team, if any team loses 2 times, initially they're all in the winners group, right? So if a team loses 1 time, they will go to the losers group, and if they are here and they lose one more time, they will get eliminated, right? So every team has to lose 2 times in order to get eliminated from tournament, right? So I can say that any team which is not inside my two groups, that is, it is eliminated, that will imply that that team has lost twice, right? So basically, to get eliminated, a team has to lose twice, right? Okay. So um basically, every team which is eliminated has lost twice. Okay. Then any team which is in the loser group has lost once, exactly once, right? That's why they are in this group. Okay. So any team which is here has lost exactly once, and any team which is in here hasn't lost any time, right? So this is the winners group, this is loser group, this is eliminated. So they are outside the two groups. So any team which is in the winners group has never lost, right? So 0 times. Then any team which is in the loser group has lost once, that is 1 time. And any team which is in the eliminated, like any team which is eliminated has lost twice. Okay, 2 times. So finally, like we want to count the number of matches, right? We want to count the number of matches. So instead, what we can do is count the number of times a team has lost. Because in each match, one team will win and one team will lose, right? Each match has a winner and a loser. So if we count the number of losers, we'll have the number of matches. We'll have the number of matches as well, right? So that's why we can just count the number of losers. So finally, what will happen? Finally, they have said to us, right, that finally only one team will remain in each group, right? After multiple iterations of the process, both groups end up with a single team. When this happens, they both play a match. So finally, what will happen is this both of these groups will have a single team each, right? There is one team right here and one team right here, and the rest n minus two teams, they are eliminated, right? This is the winners group, this is the losers group, and rest n minus two are eliminated. So what we can say is these n minus 2 teams have lost twice each, right? They have lost twice. So the number of losses is 2 into n minus 2 plus this team right here has lost once, right? So plus 1. So currently, this is the number of matches that have been played, right? And finally, also, finally, these two will play a match also, right? These two will play a match, and so there is one more match which is happening. So basically it is 2 into n minus 4 plus 2, which is equal to 2n minus 2, right? So this is your answer. All right. So it is a pretty simple problem. You just have to count the number of losses, right? And then it becomes pretty simple. Okay. So I'll just show you the code. It is very simple, obviously. Okay. Let me turn on VPN. I mean, the code is pretty simple. It is just C in n and C out 2 into n minus 2. 2 into n minus 1, I mean. Right? Int n, C in n, C out 2 into n minus 1. All right. So that was problem A. Let's go to problem B now. It says that Abraham is a brave explorer who goes where no other programmer has gone before. For his next expedition, he plans to investigate a peculiar maze. He knows that the maze is n by n grid, with an arrow in each cell that points in one of the four directions: up, down, left, and right. Abraham also knows that if he stands on an arrow, he will be forced to follow the arrows starting from that cell. Each arrow moves Abraham exactly one cell in the direction that it is pointing. If he reaches an arrow that points towards the outside of the maze, Abraham will escape the maze. Abraham doesn't know how the arrows are arranged, so he wants to plan for multiple scenarios. He tasks you with finding an arrangement of arrows in the grid such that there are exactly k starting cells from which he can escape the maze. Okay, so what they are simply saying is we have a maze, right? We have a maze which is an n by n grid like this. Okay, and what will happen is, like, there are some arrows in each cell. Okay, so let's say these are the arrows, right? So I'll not draw all of them, but there are arrows in each cell. Okay, and what Abraham will do is, like, whenever he starts from a cell, let's say he started from this cell right here. Okay, then he has to follow the arrows. So this arrow tells him to go up, so he will go up. Then this arrow tells him to go right, so he will go right. Then down, then right, then up, and then up. So he has escaped. He has escaped the maze because this arrow was up, and up is outside the maze. So Abraham has escaped the maze this way. So, like, obviously, whenever you start from a cell, whenever you start from a cell, let's say you start from here, then you will follow some path, right? Wherever the arrows take you. And finally, either you will escape the maze like this, or you will be stuck in a cycle forever. Like, for example, if you have something like this, let's say you have something like this, these arrows, and you start from here, right? Then you will go right. If you are here, you will go right. Then when you are here, you will go left, and again you will go right, and so on. Correct? So whenever you start from a cell, either you will escape from one of the border cells, or you will be stuck forever, right? So what we want is, out of these n square cells, like, there are, this is n into n grid, right? So out of these n square cells, we should have exactly k cells from which we can escape, from which we can escape. Okay. So basically, out of these n squares, we want k cells from which we can escape, and the rest n square minus k cells we cannot escape from. Okay. So we have to just construct a grid like that. Like, they have given us n and k, and we have to construct a grid such that we have exactly k cells from which we can escape. Right. So that is the problem. So let's say, for example, we have, okay, and we also have to report that it is possible or not. Like, if it is possible, then we have to say yes and then print the grid. And if it is not possible to make a grid like that, then you have to print no. Right. So let's say here we have some examples: n equals to 2 and k equals to 4. So 2 by 2 grid, and they want that all four cells should be escapable. So what we can simply do is point all the arrows upwards, like 4 by 4 grid, point the arrows upwards, right? And so you can escape from every cell. You can see clearly, right? Then 3 5, for 3 5 they have made this grid. So I think you will be able to figure out that why there are 5 for this, right? Like, why there are 5 cells for this input. So I'll leave that up to you. And then we have 2 3, like 2 by 2 grid, and we want 3 cells to be escapable. But the answer is no in that case. Like, it is not possible. So how do you come with that? Like, how do you solve this? Let's see. Okay. So essentially, the thing is that, first of all, when is the answer no? Or let's say that, when are we stuck? When can we be stuck. So that will happen if there's a cycle. Like, let's say this arrow, let's say I have a 4x4 grid. This arrow points here, then this arrow points down, then this arrow points here, this points up, this points up, then this points left, left, and down. So we have cycle like this, right? Like cell starting from here, then right, then down, here, 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 and then again we come to this cell right here. So we have a cycle like this. So if we start from any cell out of this cycle, then of course we'll get stuck, right? There's no escape. And when can, and also one more thing, if we are on a cell, like, okay, this is a cycle, right? This is a cycle, so all of these cells are not escapable. Okay. So basically in my grid, I have two types of cells, right? I have two types of cells. One is escapable and one is non-escapable, right? So these cells currently, they are non-escapable, right? Now I ask you that what other cells are non-escapable. So you can say that any cell which points towards a non-escapable cell, it is non-escapable, right? Any cell which points towards a non-escapable cell is non-escapable, right? So like, because if I start from here, I will end up on this node, and we know that uh, this node is not escapable. So therefore, this is also not escapable. So I'll mark this as red, right? And also we can say that if my node, like let's say I have an arrow like this, right? I'll draw it in white. Let's say I have an arrow like this, and so this cell is escapable, right? It is escapable because this arrow points outwards. So all the cells on the border from which the arrow points outwards are escapable. And also, any cell which points towards an escapable cell is escapable, right? Like we can simply observe this. Like there are two observations. One of them is any cell which points towards an escapable cell is escapable, right? And same thing for non-escapable, right? And one more thing, third thing is um, we need a cycle to make the cell, like to make cells non-escapable, right? Like basically in our grid, we need a cycle like this, like not exactly like this. It can be any cycle, but we need a cycle to make the cells non-escapable, right? So the simplest cycle that we can think of is simply of length 2, right? Like what we can just do is place an arrow like this and an arrow like this. So if I do this, then all the cells become non-escapable. Like these two cells become non-escapable, right? Now let's say if I want to make more cells non-escapable, like let's say in our input, our n is equal to 4 and k is equal to 6. Okay. So out of the 16 cells, I want to make 6 cells non-escapable. So as of now, I have already made 2. Now if I want to make more cells non-escapable, then what I can simply do is just point these cells towards this. Like let's say if I want to make this one also non-escapable, I will just point it towards this cell because this one is non-escapable. And if it is pointing towards that, itself becomes non-escapable. So this is red now. And this is so 3, then 4, and then 5 and 6. So like I am pointing these cells towards the non-escapable cells. And so they themselves become non-escapable. And as you can see now, I have 6 cells which are non-escapable. And so rest of the cells I want escapable, right? So for them, I can just point them downwards. Like if I have downward arrow for these cells, then they are green, right? They are escapable. And so I can point the other cells towards them as well. So like I can point all of them downwards. So all of these cells become escapable, right? So this is the thing. Like this is my construction that I can follow. So in general also it works. In general, if I tell you that how to make it work, you can simply just like let's take an arbitrary size grid. Let's say 5 by 5. So okay, first of all, one case is that what if you want all cells to be escapable? Like what if k is equal to n square? Then you can simply just do all of them up, right? If you just put all of them as up, then it works, right? Then what if k is equal to n square minus 1? N square minus 1 means you want only one cell to be non-escapable. Okay. So that is actually impossible. That is not possible because just ask yourself that if one cell, if only one cell is non-escapable, then whatever it is pointing to, like see, we want only one cell to be non-escapable, right? Let's say it is this cell. Okay. So it will be pointing somewhere, right? Either up, either up, left, down, or right. Correct. And we want, okay, so if this one is non-escapable, then of course all of the others are escapable. All the other cells in the grid are escapable because we want only one non-escapable, right? But this non-escapable cell will have to point to some cell, right? And that cell will definitely be escapable. And that is not possible because any cell which points towards an escapable cell is escapable. So it is not possible for us to construct a grid in which there's only one non-escapable cell, right? So for k equals to n square minus 1, it is not possible, right? So we need to have at least two red cells, at least two red cells. Okay. So let's say if we have k less than equal to n square minus 2, that is k is less than equal to n square minus 2, that is we have at least two red cells. Then we can simply place two arrows like this, right? So they become red. And then in this row, just do all of them. Like, okay, however many you want red cells, just do this for them. Like just left, left, left. Like for the first row, just make all the other cells left. And then from second row onwards, just make them up. Because now all these three are red. These three are red. And just make the just make these ones as up. So now they are also red because they point toward red. And let's say you want one more, then you point this upward as well. And let's say now you want all escapable, like let's say k was 11, no sorry, k was 25 minus 11, which is 14. So you wanted 11 red cells and 14 green cells. So you have 11 red cells now, and the rest of them you can just point downwards, right? So basically in the first row, like in the first two cells, just do this. And then however many escape non-escapable cells, however many red cells you want, just in the first row put them to the left, right? And then from second row onwards, put them to upward. And you will do this until you want red cells. And as soon as you want green cells, you will just fill downwards, right? And this works. Okay. So this was the problem, and I'll show the code now. So the implementation is like my implementation is I think not very good, but okay. So int nk, c in nk. If k is n square minus 1, then the answer is no. So print no and return. right? Then I have the answer vector. Then if k is equal to n into n, like if k is n square, then we have to print all ups, right? Just print all of them as up. Okay. So just print yes, and for all the cells, print up. Okay. And then just print new line. Okay. So this is the case where k is equal to n square. And yeah, and if k is not equal to n square, then you will set these two cells. So like you will set this cell as right and this cell as left. Okay. So we have 0 0 will be right, we have 0 1 will be left. And for the other cells, like you want n square minus k cells, right? Like okay, you have filled this first cell, like cell number 0, cell number 1, cell number 2. Like I am numbering like this. In my grid, I have numbered like this. That this is cell 1, cell 0, cell 1, cell 2, cell 3, cell 4, cell 5, cell 6, cell 7, and so on. Okay. So like if you want from the cell number, like let's say the cell number is k. Like let's say for this cell 3, the row number is 0, 1, 2, 3. Like the row number is 0 for this one, and the column number 0, 1, 2, 3. So it is 3. So from the cell number, if you want the row and the column, what you can do is like if the cell number is I, then your row would be I divided by n, like floor division, and your column number would be I modulo n, like the remainder. Okay. So I am doing it that way, like 0 and 1 are already filled. Then from 2 onwards, I am filling 2 onwards until n square minus k. So these many red cells I want, right? These many red cells. So the row would be I by n, floor division, and the column would be I mod n. Now for the first row, like in the first row, what I'll do is I will point towards the left, and in all the other rows, I will point towards up if I want it to be red. So if not r, that is if r equals to 0, then I'll point towards left, and otherwise I'll point towards up. So this is how I'll fill the red cells, and for the green ones, I'll just fill downwards, right? So just I equals to n square minus k to I equals to n square minus 1. I will just fill downwards for all of them, and then I'll just print the answer. Okay. So this is how it works. So I hope you understood this problem, and let us move on to the next one. Okay. So C problem is there are n wizards in a row numbered from 1 to n from left to right. Each wizard has an invisibility cape which can be worn either on his left or on his right. Harry walks from the position of wizard 1 until the wizard n and registers how many wizards he sees from each wizard's position. A wizard in position J is visible from position I if the wizard J wears his cape on his left side and I greater than equal to J, or wizard J wears his cape on his right side and I is less than equal to J. In particular, note that the wizard I is visible from the position I. Harry's list is very old, but after much work, you deciphered it. The list is an array A of n elements, where the ith element ai is the number of wizards that Harry saw from the position of wizard I. Calculate how many possible cape arrangements that Harry could have seen are consistent with the data recorded by the list, modulo this number. So what they are just saying is that there are some wizards, like there are n places, and in each place there is a wizard. Okay. So I will draw the wizard using like this, or let's say W. So there are wizards on each cell. Okay. So every wizard has a cape. Cape means the invisibility cape. That means if the wizard is wearing that cape on his right, like this, then you cannot see this wizard from the right. Like if you are somewhere here, if the person that is seeing is somewhere here, or let's say if he is somewhere here on the third position, then he cannot see this wizard. because he is wearing his cape on the right. But let's say this wizard is wearing the cape on the left, then he can see this wizard, right? And also the person can see these wizards as well. Like if these wizards have wore their cape on right hand side, then he can see them, right? But if this wizard has worn on the left hand side, then this person cannot see them, right? But okay, just note that this cape only works for this wizard. Like it won't protect the further wizards, right? That is one thing. So basically every wizard has worn it on left or right. Okay. And we have been given that from each position, how many wizards can this person see? Okay. And first of all, they have given us that the person can see this wizard, like from, if the person is at position I, then he can definitely see the wizard at position I. So at least one he can see, right? And others he can see if the cloak is on the opposite side. So this person can see this wizard and this wizard also, right? So they have given us an array. They have given us an array, which tells us that from each position, how many wizards are visible, right? And we have to determine that how many ways is it possible. Okay. Like for example, if we have this type of configuration, like we have four wizards. Okay. So this one has one on the left, this one on the right, right, and right. So basically, we have these four people, like four wizards, and this one has one on the left, then on the right, on the right, and on the right. So if you are standing somewhere here, then you can see this one because you can always see this one. Then you can see these three as well because they have one on the right. Okay. So here it is four. Then if you wait a minute. Okay, then if you are here, then you can see this one because this wizard has one on the left. Then you can see this one also because on the right. Then you can see this one also because it is on the right, and this one also. So the answer is 4. Then for this wizard, um, you cannot see this one. Like from here, you cannot see this one because this is protecting him. But you can see this one, you can see this one, and you can see this one. So it is 3. And similarly, from here, you can see this one and you can see this one. So it is 2. So for this configuration, the array would be 4, 3, 3, 2. And in the problem, they have given us the array that is 4, 3, 3, 2. And for this, the answer is 1. That is, this is the only possible configuration for which the array would come out to be 4, 3, 3, 2. So our task is to take in the array and tell them that what is the number of configurations, right? So how do we do this? Now, first of all, let's just try to formalize this or generalize this statement. Like, let's try to figure out that how can we make the array? Like, how is the array actually made? Okay. So let's say I have some wizards. Like, let's say the first wizard has one on the left. Like, okay, I'll just draw this one only. Left, right, right, right. Okay. So we have a configuration that is left, right, right, and right. So how will we make the array using this? Like let's say if I want the value for this position, then how will I find it out? So basically the value is what? The value is like how many wizards are visible from this point. Okay. So if you are standing somewhere here, then you can see all the wizards who are to the left, and also they have worn their um, cloak to the left, right? So you can see this wizard. So basically, AI would be number of lefts, like number of lefts up to I minus 1. Like if this is ith position, then up to I minus 1th position, like up to here, the number of lefts, you can see all of those wizards, right? And plus whatever are on your right, and they have worn their cloak on the right, you can watch them as well. So plus number of r's after I plus 1, including I plus 1 also, and plus 1, because you can always see the ith person, right? So this is AI. Like, for a given configuration, our AI can be calculated like number of L's up to I minus 1 and number of R's after I plus 1 and plus 1. So this is what you can calculate, right? So from this, you can actually just think about how the array would change. Like, see, if I am somewhere, like let's say I have an array LRR, LRL. Okay. So let's try to compute this. So basically, for this position, what is the answer? The answer is 1, 2, 3 plus 1, which is 4. Then for this position, what is it? 1, 2, 3, and this one, so 4. Then for this position, it is 1, 2, and 3, so 3, and so on. You can calculate like this, right? But my entire point is, how does the number change? Like, just observe that if you are at index I, okay, and you move to index I plus 1, then what changes? Like, we have this formula, right? We have this formula that our AI is equal to the number of L's to the left plus the number of R's to the right plus 1. Okay. So if we just try to figure out that when we move from I to I plus 1, then how will the answer change? So how do we think about that? Okay. So there are 4 cases, all right. Like, let's say I am at index I and this is index I plus 1. So there are 4 cases. Either it is LL, or it is LR, or it is RL, or it is RR. Like, okay, that is the thing, right? So let us take case by case. Okay. So first case is LL. Like, on the index I, it was L, and on the I plus 1, it is index R. And we want to see that when we move from AI to A of I plus 1, then how does the answer change? Okay. So in AI, there must have been, like, if I draw it for you. So this is I plus 1. So in AI, there would have been all of the lefts in this region and all of the rights in this region plus 1. So plus 1 is there in both. So I will ignore that for now. Okay. So all the L's in this region and plan plus all the R's in this region. And in I plus 1, like in the answer of I plus 1, I would have all of the L's in this region plus all of the R's in this region. Right. So what is the difference? So as you can see, in this A of I plus 1, if I have an L that is here, if I have an L here, then my answer will increase by 1, because this was not counted in AI. Like, this wizard was not counted in AI, but now it is counted, right? So if there's an L here, my answer will increase. Also, if there's an R here, like on this position, if there's an R, then initially this wizard was counted, right? Initially, like for AI, if we are at ith index, then this wizard was counted in the R set, right? But now it is not counted because only these ones are counted. So if there's an R here, we have to decrement the answer as well, right? So that's what we can do. Like, on basis of this logic, we can simply see that how the answer changes. So if we have L here and L here, and we move from AI to AI plus 1, then, like, since we have come here, so this L is counted extra. So the answer will be plus 1. So, like, if I write the value of A of I plus 1 minus A of I, then it will be 1, right? Then in second case, we have, let's say, we have an L here, we have an R here. Okay. So initially, like when I was here, this R was being counted. but now it is not being counted. So the answer will get -1. But also, when I was here, this L was not being counted, but now when I come here, it is being counted. So the answer will also increase by +1. So net change is 0. Okay. Then third case, we have RL. RL, okay. So in this case, when I was here, this R was not being counted, and also this L was not being counted because on the right hand side we are counting R's, not L's, right? And when we come here, then also this R will not be counted because we, like, on this side we are counting the L's, and this L also will not be counted because it is not a part of anything. So the answer will not change, right? And fourth case, we have RR, right? So when we were here, this R was being counted, right? But when we come here, it is no longer being counted. So our answer decreases by 1, right? So basically, we observe that whenever we move from index I to index I plus 1, either the answer increases by 1, or it stays the same, or it decreases by 1. So the answer cannot change by more than 1. Okay. So let's say in this test case, we have like this 1, 3, 2. Then that is not possible. The gap of 2 is not possible. So in that case, you will just write 0. Okay. So now from this information, what can we actually determine? Like, okay, now we know one of the cases where the answer is 0. But how do we actually count the number of possibilities? Okay. So let's take a test case. Like, let's take this test case, which is 4332. Sorry, 4432. 4432. So see, one thing that we know here is if the delta is 1, like, if we have x here and x plus 1 here, then we can definitely say that both of these cells are LL, right? That's what we can say, because this one delta is coming only in this case, LL case. So if we have an index such that there's an x on the first one and x plus on the second one, then we can say that there's an LL on these two indices. If there is a -1, that is, we have an x plus 1 on the left hand side and x on the right hand side, then we know that we have an RR, right? And if we have two indices which are same, then we can't say anything. Like, we can say that either it is LR or it is RL. But basically we know that they are opposite. They are opposite, right? So basically, um, we have 4432, let's say. So since this 43 is there, 43 means x and x minus, like x plus 1 and x. So that's why the delta is -1, and therefore both of these are RR, right? Also, there is 3, 2. So from this 3, 2, we can determine that these two are RR, right? And also we have 4, 4. So what does 4, 4 mean? They are equal, right? So equality means that these two must be opposite. So if here is R, this must be L, right? Like, if delta is 0, then either it is LR or it is RL. But we knew already that this was R. So we can make this as L. So it is LR. So basically we can determine uniquely that what is the answer. Like, from this array, we were able to determine that what is the configuration of the wizards. And this is the only possible. That's why the answer is 1. Right. So actually, in similar ways, we can find out the answer for anything. Like, if we have an index, like if we have x and x plus 1 somewhere, or if we have x plus 1 and x somewhere, then we can definitely figure out that what is the entire array using that. Like, I will generalize it for you. Like, in general, if we say, in general, let's say we have an array. Okay. So let's say we have an x here and an x plus 1 here. So we know that the delta is 1. So that means that there must be LL here. LL, right? And like for all such indices, like let's say I have 1, 2, 3, 4 up to n, right? So for all pairs, if you check like 1, 2, 2, 3, 3, 4 up to n minus 1 and n. So all such pairs which are either x plus 1 or x plus 1 x, you can just find the answer for that. Like just find the answer for them, right? For example, if we have an array that is given something like this: 2, 3, 4, 4, 3, 4, 5, or 3, 4, 3 and 3, right? Or let's say one more 4 here. Okay. So for all of these indices, like from this 2, 3, you can determine that it is LL. Then from this 3, 4, you can determine it is LL. Then from this 4, 4, you can't say anything. From this 4, 4, you can't say anything. From this 4, 3, you can say that it is RR. And from this 3, 4, you can say that it is LL, right? So basically, this is not possible because here you are getting both R and L. So the answer is 0 for this test case. So in this way, you can determine the answer for all those cells whose neighbors are not equal to itself, right? But what about those cells which are equal? Like simply what you can do is, first of all, you will populate those cells which are not equal to their neighbors. Like let me make a test case which is actually possible. Okay. Um, let's say I have LLLR. Like I'm trying to make a case from the answer. Okay. RRLL. So what is the answer for this? RRR 4. Okay, so I have 4, 5, 6, 6, 6, 6, 5, and 5 and 6. So let's say this was your array. Like just forget about this thing. Let's say this was your array. And now you want to find out that what are the possibilities. So my claim is that you can always find out, and like since you have this 4, 5, right? You have this 4, 5, you have this 5, 6, 5 also, and this 5, 6 also. So using these cells, you can easily find out the answer. Like if you have 4, 5 here, you can say they are LL. Then you have 6, 5 here, you can say that they are RR. And also you have 5, 6 here, so you can say that they are LL, right? And but what about these three cells, you will ask? Okay, and also 5, 6, so you will know that they are LL. LL, right? But what about these two cells? Because these two are equal. So how can we determine these two cells? That's the question, right? So what we can actually do is we can observe that they are equal, right? If they are equal, that means it is either LR or RL. But we know that this is L, right? So definitely this is R. Okay. And similarly for this case, we know that they are equal. They are equal, so that means these two are opposite. So since we know that this is R, so this must be L. So my entire point is that you can simply determine if you have at least one index like this, where you have unequal, that is the delta is +1 or -1, you can simply determine that what is the entire array using that. Okay. So just make the entire array using that information and finally just check if the answer is correct or not. Okay. That's the algorithm. Like my entire point is, if you have at least one pair where delta is not equal to 0, then you can simply determine the entire array using that pair. Okay. And I just showed you how to determine like this. Like I'll show you in code how do you determine, but the logic you will get like this. I mean, I told you the logic. I'll show how to implement it as well, but for now, just understand the logic. that wherever you have this del not equal to 0, you will know that what is the answer to that. Like if del equals to 1, let's say 5 or 6, then you will say that they are LL. Then whatever is here, like let's say if they are equal, then also you will know it is R. This is R, right? So you can simply figure out the entire array using this fact. So the answer would be 1 in that case. Like what you will do is you will just construct the entire array like that. Like you will just construct the entire array of L's and R's, and then you will check that is the input array actually correct, like this. And why do we check that? Like why do we need to check that? That is because, let's say if I have, okay, so for this pair of L and R, this is the array, right? Like you can verify that this is the correct array for this configuration. But actually, like let's say the input was 14, 15, 16, 16, 16, 16, 15, 15, 16. Like if the input was this, then also my algorithm would have printed this array only, because all I am doing is looking at the deltas. Like I just look at this difference, it is 1, and I say that this is LL. Then I look at this difference, it is 1, I say it is LL. Then look at this difference, it is 0, I say that they are LR. Like it is opposite. So I am just looking at the differences. So in this case, like even if my input was this one, I would have said that this is my array, and the answer is 1. But actually the answer is 0, because this configuration is not satisfied by this array, right? So that's why in the end, just check once using prefix sums. Like you can simply use prefix sums for this calculation of AI. Like for this calculation of AI, you can simply use prefix sums and just check that whatever array you came up with is the answer for that the input. And if that is so, then the answer is 1. And if it doesn't match, then the answer is 0. Okay. So I just showed you how to calculate the answer if you have at least one pair where delta is not equal to 0. But what if delta equals to 0 everywhere? Like basically, delta equal to 0 everywhere means all numbers are same, right? Like let's say all numbers are 4, 4, 4, 4. Okay. So what does that mean? That just means that at every position, you have opposite pairs, right? That means if you have L right here, then you will have R here, L here, R here, L here, R here, and L here, right? I have 7 brackets. Okay. So if you have opposite, like if you have at every point delta is 0, then you will have alternating sequence. So either LR, 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 or RL, 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 RL. So these two are the only two possibilities. If you have um, if you have an array which is like this, right? And so finally you can just check these two also. Like you have if you have an input where all of these are equal, then you can simply check both of these, that um, is it correct or not. Like for this array, is this coming out or not? And for this array, is this coming out or not? And if for both of them it is coming out, then the answer is 2. And if for only one of them it is coming out, then it is 1. And if for none of them, then it is 0. So it is pretty simple. Okay. Or actually you can do casework also. Like you can say that in general, what is the answer? Like let's say I have n equals to 5. Okay. So either I will have LR, LR, L, or I will have RL, RL, R. Like if delta equals to 0 at every point, then either I will have this or I will have this. Right. So what is the answer for this one? Basically, if you are here, then 1, 2, and 3. Right. So 3, 3, 3, 3, 3, 3. And for this one, if you are here, so 1, 2, and 3. So again, 3, 3, 3, 3, 3. Right. So basically, if for n equals to 5, your delta equals to 0, then it has to be 3, 3, 3, 3, 3. Like it cannot be 2, 2, 2, 2, 2 or something. Okay. Like if it is 2, 2, 2, 2, 2, the answer would be 0. All right. And let's say, like for even n, this was for odd n, right? And for even n, let's say n equals to 6. So either you can have LR, 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 or you can have RL, 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 right? So for this case, what is the array? So the array is 1, 2, 3, and 4. So 4, 4, 4, 4, 4, 4, or this, and this. So in this case, 3, 3, 3, 3, 3. So like if you compute for this, it would come out to be 3. And for this, it would be 4. So basically, if your input is this, then the answer is 1. Like if n is even and the delta is equal to 0 at every point, then either it has to be 3 or it has to be 4 for n equals to 6. For n equals to 6. So like if you have this input, then only one possibility is there, which is this one. So the answer would be 1. And if you have this input, then also only one configuration is there. So the answer would be 1. And if you have something else like 2, 2, 2, 2, 2, then the answer would be 0. It is not possible, right? So that's the entire solution. So like if I generalize it, for odd n, for odd n, you need to have that all AI should be equal to n by 2 ceiling. Like for 3, for 5, you have to have all threes. So if all threes are there, then the answer would be 2. And for even n, either AI should be n by 2 or n by 2 plus 1. And in both the cases, the answer would be 1. Right? Like if it is n by 2 plus 1, then the answer would be LR, 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 LR. And if it is n by 2, the answer would be RL, RL, RL. So we have only one possibility. And this is when like all the deltas are equal to 0. And if you have a non-zero delta, then you can simply figure out the entire array and finally just check it. Like just check if that is consistent with the input array or not. And in that case, the answer would be 1 if it is consistent. And if it is not, the answer would be 0. Okay. So this was solution, and I will show the code now. Okay. So yeah, just look at this. I have first the SKS handling, like okay, int n c in n, input the array n. So if count of a0 in the array is equal to n, that means all the elements are same. So that means we have all deltas equal to 0. So if n is odd, then if the first element, that is if all of the elements are n by 2 plus 1, then C out 2, the answer is 2. Otherwise the answer is 0, right? This is for n equals to odd. And for n equals to even, if a naught equals to n by 2 or a naught equals to n by 2 plus 1, in both of the cases the answer is 1. Otherwise the answer is 0, right? And then what we do is we build the answer. Like if we did not go into this loop, that means there's at least one index at which the delta is not 0. So using that, we can generate the answer. So I have this answer vector of car. Like I'll store either L or R in this. And initially it is filled with zeros. And I will store either L or R at every index, right? This final answer. So I will iterate over the array from I equal to 0 to n minus 1 or n minus 2 actually. My delta is a of I plus 1 minus a of I. If delta equals to 1, that means I would have L at I plus 1 and also L at I. Okay. So what I will do is in my vector, I will ensure that there is L at both the positions. So I have this function called expect. Like this function, what it will do, at this index I, if there's nothing, like if currently it is empty, then it will set it to that value. Like it will take two things. It will take an index and a value. And if at that index I have, if at that index I don't have anything right now, then it will add that value, right? Otherwise, if there's something, then it has to be value, right? So it ensures that it is val and it returns true, and otherwise it returns false. Like essentially, what I'm doing is, like, let's say I have an array just 4 5 4 5, like this. So this 4 5 tells me that I have ll, like ll right here. So I will look at this and I will fill ll. Then this 5 4 tells me that I have rr. So I will try to fill r in here. So I will call this function for this index and for r. But then this function will see that this v of I is not equal to 0, and it is not equal to val also. It is not equal to r also. So it will return false. And therefore I will know that I already have something in there and it is clashing. So I'll just print 0 in that case. So I will call expect I comma l, and if it returns false, then I'll print 0. And the same for I plus 1 comma l, right? So this function simply checks if there is that value there, and if it is empty, then it fills it, and if there is something else, then it returns false. Otherwise, if delta equals to -1, then I have rr at both of them, right? And otherwise, if delta is not equal to 0, like if I don't have 1, if I don't have -1, and also if I don't have 0, that means it is an invalid value, like it is more than 1. So I'll just print 0 in that case, because I cannot have more than 1 in my array, right? So I have filled some values of my vector, right? Like let's say I have filled some values, like some answers. Let's say LR, I mean not LR. Let's say I filled LL here, RR here, on the basis of my delta thing, right? Or LL, okay. So essentially, the ones that are not filled, like the gaps which are not filled, they are definitely the equal ones, right? Like if this is not filled, then it means that um, all of these three numbers are equal. Like see, what my point is that I just filled some indices using else and r's, and there are some gaps. So those gaps are there because I could not fill them, because these two pairs, like this pair was equal, so I could not fill this cell, and also this pair was also equal, so I could not fill it. So basically, any cell which is empty because there is equal there. Okay. So essentially, we want that they have to be opposite. Like my point is that if a cell is empty, if a cell is empty, it has to be the opposite to its neighbor, the opposite to its neighbor. Okay. So we can simply run a BFS or something. Like what I'll do is run a multi-source BFS from all the points which are marked, like which are already solved. Like basically there is L right here, right? And there's an empty cell to the right of it. So I can fill R there. I can fill R. And also I have to ensure that let's say I run from here also. So here I want L because it has to be opposite. But already there is R. So if there's a clash, then I'll return 0. Right. So I'll simply start a BFS like this from all the cells which are already determined. And that's how I will fill the entire array. Okay. So I have a queue here, and I will iterate over the entire array. And if it is non-zero, that is I have filled somewhere in there, Then I'll push that index into the queue. Then I have x equals to q dot front and q dot pop. So from x I can go to either x plus 1 or x minus 1, right? So if x plus 1 equals to 0, so I will set that x plus 1 to the complement. Like if v of x equals to L, then I'll set v of x plus 1 to R. And if v of x plus 1 equals to R, then I'll set it to L. Sorry, if v of x is equal to R, then I'll set v of x plus 1 to L. And then I'll push x plus 1 into my queue. And otherwise, like if it is already filled, and if there's a 0 there, I mean if the delta is 0, if a of x equals to a of x plus 1, that means they have to be opposite, right? So if they are not opposite, that is if v of x plus 1 is not equal to r plus L minus v of x, then I'll print 0, right? I'll just check that condition on this line. And similarly for x minus 1, the same code for x minus 1. So finally I have run a BFS and just filled my entire array, right? I have filled my entire answer array using this. And finally I will verify that my answer is correct actually. Like what I'll do is I'll make a prefix array and a postfix array. So this prefix array stores, this prefix of I will store that from 0 to I minus 1, how many L's are there? Okay. And this postfix of I will store that from I plus 1 to n minus 1, how many R's are there? Right. And so if you want, so prefix of 0 will be 0. And from 1 to n, I can say that prefix of I will be equal to prefix of I minus 1 plus I'll add 1 if my v of I minus 1 is equal to L. And similarly for the postfix one. And basically my answer, like my array would be prefix of I plus postfix of I plus 1. So for every index, I'll check if that is the condition. And if anywhere it is not, then I'll print 0. Like I'm just checking at the end that is my answer consistent with the input array. And if it is, then I'll just print 1. Okay. So this was the entire problem. I hope you understood. Like it has very much casework. So I hope you understood every case. Okay. Then let's move on to problem number D, which is batteries. There are n batteries numbered from 1 to n. Some of them work while others don't. Let A be the number of batteries that work. It is guaranteed that A is greater than or equal to 2. You are given n, but not A. There's a flashlight which can hold two batteries and it only turns on when both batteries work. The batteries have been shuffled and you don't know which ones work and which ones don't. You can choose two batteries and try in the flashlight. Okay. So the flashlight can hold two batteries and it turns out it turns on if both work. You want to find a pair of batteries that will work. However, you are worried about breaking the flashlight. So you want to limit the amount of trials you attempt. Therefore, you should find a pair of working batteries in at most n square by 8 trials. Okay. So what they are saying is we have some batteries, like let's say n equals to 5. Then we have 5 batteries like this. 1, 2, 3, 4, 5. Okay. So some of them work and some don't. And we don't know which ones work. And also A of them work. Okay. But this A is not given to us. Now what we can do is we can try two batteries. Like we can pick two batteries and put them in a flashlight. Okay. So we put them in a flashlight, these two batteries, and it will turn on. It will turn on only if both of them work. Right. So if it doesn't turn on, then we know that at least one of the batteries don't work. Right. And our aim is to find any pair of batteries that works. But we have to find that pair in at most n square by a queries. N square by a ka floor. Okay. So this is the problem. So like actually this is kind of a hit or miss problem. Like, if it hits you, then it hits you. And otherwise, I don't think there's a way that you can come up with this. But I'll try to explain my best. Okay. So just look at this array of 1 to n. Okay. So 1, 2, 3, 4, 5, 6, 7, 8. And let's say I have a equals to 3. Okay. So basically, I have 3 batteries which are working. Okay. Let's say they are 1, 3, and 6. Okay. So now just look at the distance between these batteries. Like, the distance between 1 and 3 is 2, right? Between 3 and 6, it is 3. And between 1 and 6, you can actually, like, it is cyclic. Like, consider it cyclically. Like, consider that this array is cyclic, or it is circle. Okay. So I'll draw it as a circle only. So 1, 2, 3, 4, 5, 6, 7, and 8. So 1 is working, 3 is working, and 6 is working. So the distance between 1 and 3 is 2. Then between 3 and 6, it is 3. And between 6 and 1, it is 3. Right. So actually, my claim is that if you have n cells in this circle, like, you have n cells, okay? You have n cells like this, and a of them work. A of them work. Then my claim is that at least one pair exists. Like, my point is that if there are a batteries that work, and in total there are n batteries, then actually I can find at least one pair with distance less than equal to n by a. Like, what I am saying is, if I have n batteries, like for example, if I have 8 batteries, okay, 1, 2, 3, 4, 5, 6, 7, and 8. If I have 8 batteries and a is equal to 3, that means 3 are working. So my point is that 8 by 3 ka GIF is what? It is 2, right? So I can find at least one pair of batteries whose distance is less than equal to 2. Like, I challenge you to give me 3 batteries out of these 8, such that the distance between every pair is more than 2. That is, it is at least 3. It's not possible, right? Because if you have 1 here, then the next one that you can put has to be at 4 at least, right? Because the distance has to be 3. And so the next one you have to put has to be at least on this 7. But then this 1 and 7 are at a distance of 2, right? So my point is that if you have n batteries and a of them work, like if you have n cells on the circle you have n points, and you have to select a of them, then there has to be a pair of points which are at a distance of less than equal to floor of n by a. Okay. And we can simply use this fact to find an answer. Okay. And how can we use this fact? Basically, what we know that there exists a pair of batteries which less than equal to n by a distance. So let's say if we knew that their distance was 1, like let's say we know that there is a pair of batteries with distance equals to 1. So what we can say is, like, we can simply query 1, 2, 2, 3, 3, 4, and up to n1. Like, we can check all of these pairs. Okay. So if the distance were to be 1, these are all the pairs with distance equal to 1, right? So one of them will give us the answer as yes. Okay. And if the distance was not 1, Let's say it was 2. Like first we'll check for distance equal to 1. Then we'll check for distance equal to 2. So we'll check like 1, 3, 2, 4, 3, 5, and so on up to n2, like n minus 1, 1, and n2. So we will check these n pairs, and if there is a pair with distance 2, then we will find it using these queries. And we can do this because we know that we'll only have to go up to GIF of n by a distance. Floor of n by a, if we go till this point, we will definitely find out a pair which is working. Like we know that there is a pair with distance less than equal to n by a, GIF of n by a. There is definitely a pair with distance less than equal to GIF of n by a. So if we just keep doing this, distance equal to 1 we check, then 2 we check, then 3 we check, and so on. We will have to check only up to floor of n by a in the worst case, right? And for each distance, we are doing n queries, right? We are doing n queries. So in total, our number of queries would be n into GIF of n by a. And like basically n square by a, right? Like this is less than equal to n square by a GIF. So we can say that this works. Our method works. Our method is basically to just check for the distance equal to 1, then 2, then 3, and so on. And that works because we will definitely find a pair with distance less than equal to n by a. And at that point, we can say that we have used at most n into n by a queries. And that is the limit, right? So this was the problem. And the implementation is very simple. Like I'll just show you. So you will take n, c in n. You will iterate from the difference equal to 1 and up to n minus 1. Like you don't know a, right? But let's say if a was 2, then in the worst case also it can be n minus 1. Actually, it can be not even n minus 1, because if on the circle you have two opposite points, like let's say this one is working, this one is working. This is the worst case, right? Then also distance is n by 2 only. So this loop could have gone to n by 2 also, and it would be fine. But okay, I just did till minus 1. So difference equal to 1 you will try. So I equals to 1. Like for difference equals to 1, you will try all of the n pairs from I equal to 1 to I equals to n. So j would be I plus difference. And if it is more than n, then just cycle back. So if j is more than n, then j minus equals to n. And then I will query for I comma j. That is, let's say if distance was 1, then I query for 1, 2, then 2, 3, then 3, 4, and so on. And int answer, scene answer. If answer equals to 1, that means we have found our pair, and then we can just exit this test case. So return. If answer equals to minus 1, that means like they have told us that if we get minus 1 as our response, then we have to exit the program because we have made a wrong query. So I just wrote this for safety. It is not necessary. Okay. Uh, but yeah. So that is the code. Like just keep doing this iteratively. Like increment the differences, and you will eventually reach n by a. Like you will eventually exhaust all the possibilities, and you will get the answer. Okay. So I hope this is clear. And like this was all for today. We were we discussed 4 problems, and I hope you understood all of them. And if there's some doubt, you can just ask me in the comment section. And like if you did not like my explanation, you can write there also. But just don't be rude. Okay. All right then. Thank you everyone. I hope I see you guys next time. Bye bye.